count since you told me after I told myself. I know. Well, what does it count for? I should make some sort of like reward, right? Like if you remind me, it's like a piece of candy or something. But then I'm gonna need to try to remember. Oh, but why would I do that? That's not helping you be a better mathematician. That's helping you learn that if you remember one little thing, you get to be lazy. No. All right. In student.desmos.com, your code VST very slippery turtles, tortoises or turtles, but you can't put words out. Oh yeah, but slippery. That's why he's slow. Eight funny penguins. And then I'm pausing you so we can talk about what we're doing. When we talk about the two variable situations that we've now started doing, right? Y and X are our two variables that we work to graph and make lines and stuff. Sorry, yeah, the only trash can's back there, to be honest, because I had to take some food trash out of here. Do you think every two lines will intersect at some point?
No.
Avi, hey, look at him.
No, because if you have a line that's y equals 3 and then you have a line that's y equals 1, they're never going to intersect.
Why? What are those lines?
Straight lines across.
Yeah, what do we call that relationship, Josh? Parallel. So parallel lines aren't going to intersect. What about lines that aren't parallel? How can we figure out when they're going to intersect? So this activity that we're about to work through is all about the intersection of those lines. So go ahead. Intersection of two lines. Kind of. So everybody's starting on screen one. Remember, if anything happens with your computer, the code is always up at the very top.
My computer just died and tuned into
You're going to be a trifecta. That means perfect, right?
Yes.
I'm going to walk away from that. If she tries to give you Kool-Aid, avoid it.
We like red Kool-Aid the best.
Hey, think critically. Do not let yourself answer questions too quickly. We're pretty split. Look at this. We're pretty split. I've anonymized you, right? Because we talked about this as a safe environment. I don't know, what we think is pretty split. Wow. This definitely screams gifted student, not. Subtract to get 8. Add to get 1. It's Gauss. Yeah, Gauss. You know what's amazing? You know all of the answers ever be served outside of this activity. Right now, I just need to work on this activity.
How come you anonymized us?
How what?
How come you anonymized us?
Because 1, I like the mathematician's names, and 2, I want it to be a safer environment for us to make mistakes and be wrong?
Nobody will ever know. I don't want to. Your fingers are literally like arrow keys, Bear. Look here.
Oh, you said wait. So you have your graph paper, right? And a few of you have actually started using it. Surprise, surprise. We have two numbers, right, that when subtracted get what? 8. And the same two numbers, when added, does order of addition matter? No. So I don't really care which one's X and which one's Y. I just have two numbers. Right, so couldn't we write those two things down to help us explore this idea?
Yeah.
So I'm looking to see some pencils picked up and moved and like this put on your paper potentially.
I figured it
Well, I don't know the answer. Process.
I have the process.
You have the process. What is the process?
You have to. So, wait, can I come up to the board?
Sure. It's on my board.
Yes. So, first you want to because there are two variables, you want to try and get only one variable in one equation. So you use the other equation, and we're gonna use y, and that would mean 1 minus x, right? So then you convert this into y because, yeah, convert it.
Isolate, right? Not really convert, but isolate.
Well, yeah.
Sorry, just when we say convert, we're normally using a conversion factor, like 3 feet in a yard, or things like that. That's why I just wanted to correct the vocab.
And then that would be 2x is equal to 7, and then x is equal to 5.
I'm confused.
Yeah.
At least. I don't know.
You
if
got the
anyone
right
else is.
answer, but
Because, you have to put y as 1 minus x, and so it'd be negative y, so it's negative 1 plus x, because you put.
Oh, you didn't show your work, and
Yeah,
that's why we're
I
confused.
I did show my work.
Ah, you skipped one step.
How did I skip a step? Oh yeah, I did. Oh yeah, I did.
So Alina took this, and all you really needed to do was show that. So Alina substituted in. So right here, work that wasn't shown. She subtracted x and subtracted x. Guys, show your work. Especially so people know what you're doing. So that's how she got y equals 1 minus x. She turned this into y form. Are you with me?
Yeah.
Write that down. Take a moment. Show your work even. Yep, we subtracted x from here and we subtracted x from here. I just wrote it kind of small so it becomes 1 minus x. Logan?
This is simultaneous equations.
Yeah, it's a system of equations is what we call
Can I
it.
show how I did it?
Hang on just a second because we're only halfway through this way. Alina then did x minus parentheses 1 minus x
Yeah.
parentheses.
I forgot about that.
Work she didn't show. Because this y got replaced with this. Does that make, or really, what are the questions here? Sorry, I need to stop asking, does that make sense? It's too easy to answer yes. You want to see the next step and then potentially ask the question? Because I see the wheels turning, but I don't know if they're gripping on. This distributes and does the opposite of everything in the parentheses. Opposite of 1, negative 1. Opposite of negative x plus x. Are we with me? Avi?
Definitely.
Can I what?
lost you about like the third. Never mind.
So, if we restart, just to clean this up a tiny bit, we had x minus y equals 8, x plus y equals 1, right? Are we all cool with that?
Yeah.
Then, either of these, Alina could have isolated, and she chose this one because y is already positive. Now, again, there are many right ways to get to Florida.
X is also
Well, right, but up here y is negative is what I'm talking about. So if she put this into y equals form, first y would be negative, then she could fix that. But Alina subtracted x from both sides, which can't actually happen, quote unquote, so we just have to write it out. 1 minus x, or 1 plus negative x, if you wanted to. Are we with me there? Then, she said, because these are two different equations that we're looking at, I can actually replace part of the other equation with what I found out here. Now, if this ends up not working, the lines are parallel, and they just don't ever intersect. So Alina took this and plugged it in for the y, because it is y, right? She replaced y, and that comes over here and becomes x minus parenthesis 1 minus x parenthesis equals 8.
Oh, yeah, that makes sense.
Then, so this method is called substitution, right? This becomes x minus 1 plus x equals 8. Are we still okay there?
Yeah.
That noise is great. Oh, yeah, I get it now. X plus x, 2x minus 1, right? Because we just put the two positive x's together. Then, showing our work, add 1 to both sides. 2x equals 9. You're thinking of 2y. And now it depends on which one we solve for. Divide by 2, right? Is the thing still being done to x? That's what Alina did. Right, and then I'm showing you something you don't have to have mastered right now, right? We're kind of introing these skills, but I need you with me. As some people are like, I don't know how to do this, shut down, abort. Like, stay with me. This is the one number. We know that it has these relationships, right? I can plug that x into either of these and figure out the y based off of that. Or, guess what? Y is 1 minus the x value we now know.
So, y equals 1 minus 4.5?
Y equals 1 minus 4.5.
What if I was on the number 12 and I also just figured that out? I was following along with you guys as I did it.
Whatever.
What is that?
No, this is 1 minus. 1 minus. I'm showing my work. I'm showing my work. And that's how we can solve. Jump back into your Desmos. I meant to pause it before I did this. I don't really want to answer questions right now. I just want you to engage with Desmos. Okay. Okay.
If you switch this around and make it 10x plus 1 instead, then it's y equals mx plus b basically.
Yep, it is the y equals mx plus b form.
Yeah,
Yep.
he's not.
Wait, so
He just lost his break. He
where,
can't talk right
how is
now.
like, wait, so
So he started so excited that I'm not gonna talk to the whole class.
okay,
Because
so
you're not gonna
this
talk
is
to
one
us.
line, right?
Yep.
And he
This is
started
the
out, he
other
was allowed to
Yep.
talk during transition during class.
Where they intersect
break,
is the values that
and
you just found.
lunch in the
Hmm?
bus ride home.
What
And
do you
now
mean
he's
they have
lost
to?
all transition between
There's
classes
no
talking. Break.
You're right, but why?
He lost all lunch and left. He has to wait until two people get off the bus.
If you put them both into y equals mx plus b form, they don't have the same
Yeah, he
slope.
just lost the break.
And because they don't have the same slope, they're not parallel. Yeah.
wait,
Yes,
yes,
we're
figured out. Oh, that's what I thought at first.
Yeah, it's that negative positive thing. Yo. Okay.
What will it look like when we see everyone's points? Like 16 and 24. I like 16 and 24 better.
Tomorrow's a Friday. I'm looking to it until 1:20.
So here we've plotted your two numbers as ordered pairs.
Grandma Leak says it looks okay.
Oh. Wait, why does yours say 0?
So zero.
Oh, it's
What did yours say?
Who's Michael?
4.5 and negative 3.
Who what? 4.5 and what?
Negative 3.5. The answers with I'm so confused.
I won.
Oh, it's because it's everybody's points.
What's the code right
VST8FP.
Okay, so everybody here, no, not everybody. Is this trying to tell people that y equals mx plus b isn't the only way to know what the last two? Because it's not the word. We figured it out too. And then you paused it.
I accidentally closed my email and I need to pull it back up before I do what I was going to do. I'm good, thanks. Is it me or is it warm in here? Like,
It's very warm.
okay.
Oh, look at those two waffles.
So, as I went home to let my dog out, who is on some pills so that she needs let out more often than normal. These are two of my pups, Sebastian and Timber. They are Siberian Huskies, and almost always, when we're out walking the dogs, people love to tell us that they are sled dogs. And why they think that is the Iditarod is a sled race where dogs pull sleds, right? If you don't know about the Iditarod, it's pretty sweet. There's a pack of dogs all hooked up kind of like reindeer and a dude on the back of a sled, kind of like St. Nick, I guess, and they run through like Alaska, and it's pretty cool. So,
Until the dog goes crash through the ice and they all drown.
yeah, well, that shouldn't happen at the Iditarod, which is a course that has been like made specifically for this. So hopefully that wouldn't happen, but you know, thanks for taking it there, Nancy. So when we talk about the Iditarod, there are checkpoints, right, that let people know first off that you're still safe, and second off how you're doing, right? Are you winning or losing or right in the middle? So Jola and her team of dogs made it through the first 5 checkpoints. Her buddy Evie left Nome. Nome's a place, not G-N-O-M, not Nome like lawn gnome. That starts with a G. This is Nome, Alaska. So Evie left Nome on the day the race started in an effort to meet Jola after and offer encouragement. Evie traveled along the route towards the racers on her snowmobile, right? So Iditarod track is circular. It comes back around. They're going opposite directions, right? one person dog sled, another person snowmobile. Okay? With me? It's like somebody driving the wrong way during a race car race, right?
Yeah.
So, this is why we talk about systems of equations. All those kind of famous problems like a train leaves the station at such and such time in such and such location, going such and such speed, and another train leaves this other station at such and such time, going such and such speed. And, oh no, they're on the same track. Oh no, we have to figure out how long we have before they hit each other. Like, that's a systems of equations
Just hit
problem.
the brake now.
No, because there's inevitably no break in these problems, right? Like, it's always one of those, like, we gotta switch the track. So, when we talk about a system, I'm gonna unlock Desmos again, but I want to make sure you like conceptualize what we're doing. When we talk about a system, especially when we talk about plotting points and determining things, this is what we're talking about. Is if two things are going different directions, right? The slopes here show us the different directions. Eventually, they will have an intersection. So when, I forget if it was Alex or Avi or who asked me about a problem that I pulled up from my Desmos, and it said that I used -8 and 0, because 0 minus -8 makes 8. Right? Those numbers would work, but they're not the only two numbers that work for that part of the subtraction problem. So if you are reading as you go, do not jump through these. Think of two numbers that have a difference of 8. So, like, you read this stuff and answer it. That's how you get here, and that's why we may not have the same numbers. Does that make sense? So keep working on this. We got like 20 minutes left, but read. This doesn't work if you don't read. Huh. Big surprise there. Unpause.
Oh wait.
Now, could you have told me that before you walked in here? said that like it was a realization. All I'm trying to say is the stuff we do in class when we engage with it benefits us. Right? We learn from it, we can do new, cooler things. So when we're talking about like codes and like systems and things like that, this all ties together. Right? So like when we devise different codes or ways to solve things, when we have two things that interact with each other, that's exactly what we're looking at here.
Oh, I got it. I have it.
So this is interesting. We have a lot of different points that apparently satisfy a rule, and they're all making what looks like a line. Riemann. What? Because I know these are all famous mathematicians. Yeah. So the Riemann sum theory is a very famous mathematical conjecture that Bernard Riemann, not Ryman, or you know what I mean. So I just know how to pronounce his name because he's famous. It's like Johnny Depp, right? If somebody was like, "Oh, Johnny Depp," and you're like, "Oh, Johnny Depp." I know, but it's not.
You would not believe how people pronounce some things.
Yeah, my first name too.
How do you mess that up? People call you Mika.
Any wrong pronunciation you can make, I've probably heard it from telemarketers.
Her name was Marissa, and we're just like, oh, Marissa? Mika.
Yes, that's a popular one, Mika.
Mecca. You from Mecca?
Or they just call me Mike and they don't even try.
Mr. Hudson, you have a jar of Skittles.
I do.
Are you going to make us do that problem where all of us make our guesses and then you average them out and try and come close to the actual number?
That might be a holiday activity involving Skittles or M&Ms or something, but these are just mine for eating. We will do math with a jar of candies, but those are just mine for eating. So get creative here. I like that some people already are. Right? Think of two numbers with a sum of 1. There's a lot of them. Now, I get that people are being creative in a ridiculous manner, but if we're going to then go graph these things, these are actually more useful. So like 0.25, 0.1, 0, -3, those are way more useful than -1,000, because we're just not going to be able to graph that. Right? So while this might be true, depending on what your second number is, you're not going to be able to graph that. So check out this as we plot those points. Baby shark?
No. Baby shark, baby shark. Ben for Mr. Nathan absolutely hates that song.
So I'm guessing he wasn't the one who had you play it in band?
Yeah, people just randomly
He would have randomly started playing. Not a full Illuminati, you'd need a third one. So this, with one of the axes. This is where we're tying this back together.
Yeah, that was my answer that this would happen.
This is where we're tying this back together to our linear equation. So earlier, I forget who I was talking to, but they said, these lines have to cross. And I said, okay, why? It was Alina. And we were looking at them, and first we said because they have different slopes, and then we were like, wait a minute. If the slope is the thing in front of the x,
I know.
but when is the slope the thing in front of the x? what form does our equation have to be in for the slope to just be the number in front of the x?
Has to be y equals mx plus.
Has to be in y equals form, right? So when you look at what Riemann has right here, Bernard Riemann has x plus 1 equals, or sorry, x plus y equals 1. The slope is not 1, even though there's a 1 in front of this x, because it's not in y equals form. So Hermann Minkowski put it into y equals form by subtracting x from both sides. And now that it has a negative slope, it's going down. Its y-intercept is at 1.
Who is Aristotle?
You don't know who Aristotle is?
Well, no, I know.
I'm jealous of the person who got Aristotle.
Now, I was about to say there were a couple iffy ones. Now, Logan, you made a very astute observation, which means like really good, really positive. I might have to pause this to get Logan's attention.
Submit my number. You have to just for like half a second.
Sure, but then you have to talk to the class.
He did it. Okay.
Okay, so you made a really astute observation when we were chatting. Do you want to tell the class what you said? Like, oh, I get it now. Like, I get what's happening.
So basically, we're solving an equation with an equation.
Giving me, well, like, what was one of the first things that you said? I really like that.
Well, the point where the two lines intersect is where both of the equations work for that is done.
Yeah, he said it even better. These are his words, not mine. He said that point is where the criteria for both situations works.
Is met.
Yeah, is met. So there are a lot, ladies. There are a lot of number pairs that can make this happen. There are a lot of number pairs that can make that happen, but there's only one pair that make both happen. And if we want the this and the that, we gotta find that intersection point. The this and the that. So I will unpause. You can keep working on this for a few more minutes, but I need to make sure everyone has our homework sheet for tonight. What is this? 521? Yeah, 521, right? Is it?
No, it's 521.
You gotta stop that.
What am I doing?
Making me feel like I'm wrong, because I trust you. Hey, real quick, raise your hand if you need one of these, and I will get around. This is the 521. This is today's homework. Do I what? Oh, I still have more. You know what I mean?
Yeah.
Many homework.
0 plus 6.
Thank you.
Just trying to sneeze.
I have a lot of these still, which means some of you don't have it. So I know we're in the middle of like sickness, but this has Leslie and Gail running a race, I believe, or no, to getting to school.
Parks and Rec?
It has a giant graph on the back because I'm nice. Seriously, I have too many extras. Nobody else needs this. Bianca, did you get one of these already? 521. Okay, they're up here in my bin.
Are you collecting homework anything?
We haven't had that much for this chapter yet. So this chapter, and a couple of you have come and met with me and asked me about it. If you'd like to put your Chromebook away, you may, and you can just work on practice.
Hey!
Is that Curtis talking here?
Yeah, like that.
Are these real people? The name? Are they real people?
Well, I'm sure there's a real Leslie and a real Gail, but...
Is there a real Aristotle?
Oh, these are all famous mathematicians, if you haven't really heard me say that. So yes, they are definitely real people, and they are why we know and have a lot of the things we do today. So, guys, this is this chapter, And as I've told a few of you who really like Desmos, I try to incorporate Desmos at least like once a chapter if possible. We have another opportunity for Desmos this chapter, so again, like, please be cool with Desmos, and it will let us like skip regular lesson days because that learning comes from the discovery in Desmos. This is the whole chapter. So as you can see, there's only really 6 homework, 7 if you count closure. So I planned to collect your homework as this chunk, 511 through 522. So I'll collect it next week. And then this chunk, which will involve closure and probably potentially a reviewed game, like Giant Jenga, like on the smart screen sort of thing, because we have a little bit of wiggle room in the schedule before Turkey Bowl, right? Because that's what we're kind of working up towards, is that break. So we will collect homework next week. If I just told you I'm collecting 511 to 522, and 522 happens Monday, when would I be collecting homework?
Tuesday earliest.
Wednesday earliest. Remember, I don't do the next day. I give you 2 days. But guys, like, some of you are falling in a hole of I don't care about it till it's in math. Don't do that. Do it now. Take it home this weekend. If you want the next homework that will be on that homework collection, it's here. It's actually right here. Actually, I'll put it over here. It's there. I like how you and I both. Get it now if you want it now. Get it now if you want it now. Yep. Or wait. There's 522 tomorrow. Am I losing my mind? That's why you said Tuesday, isn't it, Serena? Yeah, I can't keep track of what day it is. So 522 is tomorrow. I could collect as early as Tuesday, but I'll probably wait till Wednesday anyways, just because I just said that. So we'll collect homework on Wednesday. Let's just say that. So for those of you that want to write when things are due, do Wednesday.
Do like a fake collect on Tuesday?
Sure. Yeah, we'll do the soft collective if you're done with it, if you have it. Yeah, we'll do that.
Okay.
And then I need you to start putting Chromebooks away, please. Hey, with all of these people, if you're curious, Google their name. The mathematician result will pop up. I promise you. So even if I just Google the last name, but if I go Google Bernard Riemann, since we were talking about him earlier, Simon.
That was us.
What? Of course I'm not right.
I got the robot.
Bernard Riemann.
I think actually I don't know. I'm pretty sure. We're a meal. Aristotle. I don't know.
Aristotle.
That moment when you failed the I'm not a robot quiz twice and you question your own existence.